Salutations, you viewers across the world. This is Chico Squared, your host. This is a production brought to you by Falme Media Educational TV, the best media company in the world so far. Right. Today we are going to be looking at a concept known as organic chemistry. So I'm going to just give an introduction of organic chemistry. This lecture is more targeted towards IGCSE, Cambridge, and O-level, and also for the A-level students who want a foundation of organic chemistry prior to the deep nitty-gritty concepts that have to be known. So, organic chemistry is the chemistry of carbon compounds, right? Carbon is a very important element in the planet because carbon has got some unique characteristics that it has. And these unique characteristics are responsible for carbon being able to form numerous compounds that have got an economic significance to humankind. So hence it was very imperative that they introduce a branch that specifically deals with carbon compounds, with the exception of the carbonates, the carbon dioxide, the carbon monoxide compounds are not studied in organic chemistry. Now, so in organic chemistry, one thing you need to understand is that carbon has got the capacity of forming 4 stable covalent bonds. So the first principle you need to understand is that each and every carbon atom is supposed to be surrounded by 4 covalent bonds. And the second aspect that is of significance is also the issue that involves carbon, homologous series, all right? We need to understand homologous series, right? We have homologous series, then we have functional groups. So these 2 fundamental concepts are going to form the basis of our lecture today. Right, so homologous series that we're talking about, a homologous series is a family of organic compounds that have similar functional groups. By a functional group, I'm talking about a group of atoms that give a specific family its characteristic. Regarding my example, family 1 in a sense, remember when Mastaka was selling in HT, which you characterize as family. You same applies the homologous series, right? To the one actually similar, but the same. In a similar, even though my compounds actually are one and right? So among the most important homologous series that are going to be studied on the IGCSE include the following. We have a homologous series known as the alkene. All right? We have the alkanes. So alkenes and alkanes are special organic molecules known as hydrocarbons. So by hydrocarbons, we're talking about compounds that contain carbon and hydrogen only. So among the hydrocarbons, we have the alkenes, the alkanes. We're not going to be talking about the alkynes. We have other homologous series known as the alkynes. Right. So let's talk about the alkene. The alkene homologous series is characterized by a double carbon-to-carbon bond. All right. And these ones are known as unsaturated hydrocarbons because this double bond can facilitate addition reactions to take place. So we're going to be explaining those addition reactions. We have the electrophilic addition reactions, blah, blah, blah. But I'm going to, it's a subject for another day. Then we have the alkanes. The alkanes are characterized by single bonds, okay? There are single bonds all over between the carbon and the hydrogens. There are single bonds, and these are called alkanes. And alkanes are generally unreactive because they are called saturated hydrocarbons. So the reactions of alkanes are actually limited on that basis. So this is what happens here. As the number of carbon atoms increase in a particular homologous series, the physical characteristics also increase. The boiling point, the melting point will also increase as you increase the number of carbon atoms. And the name of any particular compound is dependent upon the number of carbon atoms that are there. So there are very important prefixes that we're supposed to know. If there's one carbon atom, it's called meth. If there are two, it's called eth. If there are three, prop. But for 4, pent for 5, hex for 6. So the other name that's going to come after these prefixes is also dependent upon the homologous series that we're actually dealing with. So all the alkane homologous series, right, they end with an N. So we have methane, ethane, propane, butane, pentane, hexane, octane, etc., etc. We can even reach up to millions and millions of carbon atoms, all right? Then if it comes to the alkenes, all right, they have an in. And for the alkene homologous series, we don't have one carbon atom, all right? We start with the ethene, right? This one is ethene over this side, characterized by this double bond with 2 carbon atoms. Ethene, propene, butene, pentene, etc., etc. As we move along this organic chemistry series, we are going to be explaining further, particularly on the EUPAC system of nomenclature. EUPAC stands for the International Union of Pure and Applied Chemistry. They've got rules and regulations regarding the naming of organic compounds. All right. So, now, we've got other homologous series that are not hydrocarbons, all right? We have the alcohol homologous series characterized by an OH group, right? My alcohols A contain this OH thing. And the alcohol that is consumable by human beings is ethanol, all right? So every type of alcohol, you know, we want to ethanol, whether it's Hennessy, whether it's Johnny Walker, or whether Cambra, Kamukura. But ethanol is more, but magazine we are, my fermented we are, all right? We also have various diverse types of alcohols: methanol, ethanol, propanol, butanol, methanol, non-methylated spirit there. Now, that's our Girwani. I'm just kidding. Say no to drugs, as my fun is, right? So we have the alcohol homologous series, right? We have the carboxylic acid homologous series, right? The carboxylic acid homologous series is characterized by C double bond O and OH, right? This is where you have the ethanoic acids. Ethanoic acid is vinegar, all right, as we know it, right? We have alcohols, we have carboxylic acids, we have esters, right? We have esters are formed between a reaction. It's a condensation reaction between an alcohol and a carboxylic acid. And some of the examples we have ethyl, ethanoate, right? My esters, right? Then my aldehydes, my ketones. Right? These ones are for the advanced level curriculum, but we're just going to mention them. We're just going to pass through them, but not in greater detail. Tinema esters, tinema aldehydes, tinema ketones, tinema amine, right? Like the amine, all right? So those who do biochemistry, basic advanced level biology and O-level biology as well, you are going to encounter this amine homologous series NH2 amino acids, all right? Just a quick reminder, this is an amino acid, right? Amine, we have an amino group, and then we have another group that distinguishes between the different types, and the carboxylic acid. Alright, we're going to talk about these aspects in more detail. We're going to talk about these being dipolar, Zwitter ions, etc., etc. So just stay tuned to our video, subscribe to our channel, right, ring the notification bell, so that Patinongo release a video chat. You're supposed to be the first person who want a video. Right. So this is the basic aspects of organic chemistry, right? It's a diverse world. We're just summarizing. We've got things like isomerism, all right, whereby there are some organic compounds that have a similar molecular formula but different structural arrangement. For instance, butane. Now, butane is called C4H10. 1, 2, 3, 4. Right? Butane is called C4H10. So this is a straight chain isomer for butane, C4H10. And then we also have C4H10 that is in this structural arrangement. Alright? So you can see these two molecules have C4H10. They are called C4H10 on the molecular formula. But they've got a different structural arrangement. And you're not going to be surprised that these two molecules have different physical properties, regardless of them being the same molecular formula C4H10. That by the UPAC standard of nomenclature, this one is called 2-methylpropane. But we're going to have a video on that. The name compound it was say, why are we calling it 2-methyl? We have a methyl group on carbon atom, 2 straight chain and 3 carbon atoms. This is going to be discussed in more detail as we proceed to continue with our lecture series. So, viewers across the world, this was just the tip of an iceberg. The iceberg actually extends vertically downwards. So viewers, I hope you've been enlightened and I hope you've been inspired to learn and to put more effort in your academic studies. Because my subjects are not chemistry, size, no, but not size. I told size of my subject, so I thought it's another world, in a language. You will never hear this being discussed past how could. Alright? So my subjects are they require you to study, alright? Use the correct study techniques, meditate upon what you have learned, improve your recalling capabilities, and you are going to see that you are not going to have any problem whatsoever. Viewers across the world, Chico Square is your host. Be blessed, stay blessed.